check.
Dutch for cheers.
Yeah. Just as my tea's run out. Tragedy.
Oh no.
I'm trying
Just
dry
got fresh
January, which I can't recommend to anyone. It's a terrible idea.
Bad for your health, that.
I'm doing dry life. Imagine that, Chris. Ugh, look at his face of disgust. Oh.
I've done 16 days and it's been miserable. So.
You get used to it. The miserableness gets tolerable after a while.
Does it? Is that life? Miserable.
No, like at the end of the day, you just get used to it, and it just becomes like the new normal, to use one of those horrible phrases.
All right, let's smack straight in. So, welcome to Beyond Binary Thinking, Sean. If you could please introduce yourself, what you're about, and why you're here today.
Sure. Yeah, as you said, my name is Sean Kenny. I'm the host of Rock Logic with Sean Kenny on YouTube. We're a podcast that deals with advanced nuclear technology, rare earth materials, and as it relates to geopolitics. And yeah, we're just basically the whole purpose of the show is just to talk about really cool advancements into advanced nuclear, particularly molten salt reactors, and more importantly, the process applications that you could apply to that for various types of industries, whether it's renewables, synthetic fuel manufacturing, water desal. We talk about all that on the show.
Beautifully teed up. Yeah, so I was having a conversation with you on Podcast Guest Exchange.
Yes.
And I remembered I was sailing and my housemate's cousin went into this long rant about how thorium nuclear plants would have been much safer, but they didn't make nuclear warheads, and so the military industrial complex banned their... Anyway, I had all these ideas rattling around in the back of my head. And as soon as I saw your podcast come up, I couldn't resist being like, okay, so... What's the deal? What's the story?
Okay, so just that one sentence right there. There's just so much to unpack there. I don't even know where to start. So
let's not. No. Before we go deep on thorium.
Yeah, don't get ahead of ourselves. Come on.
That's the exciting teaser for later. Let's start with just some basic misconceptions and myths about nuclear energy and why it's so unpopular.
Right. So I mean, the biggest thing about nuclear power, and I'm sure all of you know, is the whole industry got started on the back of the bomb with the Manhattan Project. You know, we were trying to develop nuclear weapons to fight the Axis powers, and then later on, we were trying to find peaceful applications. Like, hey, we've unlocked this tremendous energy source that's 1,000,000 times more energy dense than that of a carbon-hydrogen bond. How can we apply this? And what really got the industry started was really through the military. So we had this guy, his name was Admiral Hyman Rickover of the U.S. Navy, and he envisioned a future in where the U.S. Navy would just have fleets of nuclear-powered submarines operating in the Arctic Circle for months at a time, never having to refuel to fight the Soviets. And there were several companies that were contracted under this. And they invented what was referred to today as the light water reactor. And as of this moment, about 99.98% of the reactors that are in operation are light water reactors. To give a little bit of a generalization of how that works in layman's terms, is it's liquid moderator, solid fuel. So you have solid fuel uranium fuel rods that go into a vat of water. They superheat water that's highly pressurized to make steam. And that high pressure steam spins a turbine to generate electricity. And, you know, I would argue, as many would, that that's probably the least efficient way to produce electricity. You're only using about...
It sounds like a very fancy kettle. I went into it, it was like... Right, you're boiling water in a very convoluted way.
It is, and to make matters worse, because you're using it in the fuel is in solid form, you're only able to use less than 0.5% of that fuel before the zirconium fuel rods get exposed to all these nasty materials, and it just becomes useless. Now, you would think, oh my God, you're using only 0.5% of this fuel. Why are you using this incredibly inefficient process? Well, that less than 0.5% is more energy than burning 10,000 tons of fuel per day in coal, or how many, trillions of cubic feet of natural gas that we burn on a regular basis, at least in my country, to produce the same amount of electricity. So even though it's the, oh, go ahead.
Sorry, I was going to say, don't get us wrong, but there's pretty much most energy production systems use something for boiling something to turn some turbine. It's just,
traditionally,
it's the fundamentals. There's no clever
they're all
way.
Just big kettles.
Yeah,
pretty much.
And the light water reactor is no exception. That the only difference is we have to highly pressurize it to many multiples just to get the same bang for the buck. So it's like if you guys ever had I don't know if you guys have one of those Instant Pots, but that's basically what it is. Is you're pressurizing that water by many multiples so that you could get the temperature above 100°C, because 100°C is just not that efficient. You can pressurize
dangerous things, those.
It is.
They're bloody dangerous.
And we had an entire 3 episodes basically just talking about the inefficiencies of the light water reactor and all the things that you have to do to make a light water reactor relatively safe for commercial use. I get a lot of people. Oh, yeah. I
just wanted to ask, then what happens with the fuel? Maybe you're going to get to that. Sorry, what happens with the waste?
Oh, yeah.
Once the rods are once we've used that 0 or 0.5% of energy or whatever it was, then does the rest go to waste, or what's done with that?
So it's a good question. So I can't speak for every country. In the United States, what we do is once it's time to refuel the reactor every 18 months or so, what we'll do is you'll shut down the reactor, wait for decay heat to stop. You take the fuel rods, you basically put it in a giant pool, essentially, until decay heat sort of just stops. And once it's cooled up, you basically put them in these giant concrete containers. Usually it's stored on site. There are a lot of misconceptions, and I've had people commenting on my channel about where do we put all this stuff? I mean, do we put it in Yucca Mountain? And I'm like, well, yeah, we did have a plan to put all this stuff underground in Nevada, and that got canceled many years ago. But right now, all of the fuel that we have that we have used as spent fuel is basically stored on site at whatever nuclear facility generated the waste in the first place.
You do have a nuclear reactor in California, don't you?
We actually used to have 2. We had San Onofre, which was in Southern California. That got decommissioned about 7 years ago.
And the waste is still on site there, isn't it? It's still. I know there's a load of political problems about getting it moved.
Yeah, and I don't. To be completely honest with you, I don't know where that what kind of track. I mean, I don't know what they plan to do with the waste. I mean, chances are
just safe where it is.
They're probably. Well, the real thing here in the United States is, and this is also something that we talk about on the show, is there's amongst politicians, there seems to be this either very you have a pro-nuke stance, which you see along more the right. Some of the left will be very, very anti-nuke, like we do not even want to consider it. It's renewables all the way or nothing, solar or bust, wind or bust, whatever. And then you have some people who are more center left. They're like, well, we like nuclear power, but we need to have a solution for the waste issue. And the thing is, and something I talk about very much on my show, I've actually had several interviews with industry experts that are building said reactors that could burn said waste as fuel, talk about those solutions. And I'll go into a little bit more detail on that. But just to be clear, everything that I'm talking about in regards to how we deal with nuclear waste is just my country in the United States. That's how we handle it, which is a way of saying we really don't handle waste the way that we should.
As far as I'm aware, most of the UK sites also do the same. After they get decommissioned, they sit with the waste on site, other than what it's used for, which I assume you're probably going to go into in a second.
Well, no, that is for the most part, yes. They have been a little bit more forward thinking into considering using fast reactors, and I believe your government has actually worked with actually Moltex, which is a UK company, is looking to build a special type of molten salt reactor that burns nuclear waste as fuel. So once they get approvals on that, that might change very much for your country. In regards to France, their nuclear program is actually very robust because France doesn't have abundant amounts of uranium-235 in their country.
Hmm.
So they made a long-term decision back in the mid 70s that we're going to have probably the most robust program for recycling and reprocessing nuclear waste. So there are ways that you can reprocess existing solid waste and get a couple more bites out of the apple. So you're able to get basically generate a lot more electricity using the same amount of fuel and thus have less waste stockpiles. The amount of waste that France has actually produced in the last 3 decades takes up like a very small warehouse in central France. It's actually pretty amazing. I remember watching this documentary talking about it, and this guy asked how much nuclear waste was used to power the city of Paris for the last 3 decades. And the guy pointed to the corner of the room and said, those 3 barrels right there. And literally, when I say barrels, it's like the same stuff that you would store like, you know, a barrel of oil in. It's like, it's relatively small. And when you put that in a comparison, like Paris, France specifically, it's a relatively old city. Their wiring is not the best when it comes to, energy efficiency. They're not the most energy efficient city, yet you're able to produce enough electricity to take up, you know, the amount of waste is very small by comparison.
So if I remember right, the process you've got to go through is is it a breeder reactor and a synchrotron? You send it back through and spin it back up again. And
not exactly. So a breeder reactor is essentially a reactor that produces more fissile material than it actually consumes. And the reason why we were looking at breeder reactors back in the 1960s and 70s is we just had this idea that there was only a finite amount of these materials that we could use to power these reactors, and that we couldn't keep building reactors the way that we did back in the 1950s, that we needed to do something completely different. And there were several projects. There was the fast breeder reactor, which uses fast spectrum neutrons to achieve fission. And then the thermal breeders, like the molten salt reactor experiment, that is kind of where thorium kind of played a little bit of a role there. And I'll get to more details about that later, because I'm sure you guys have a bunch of questions about thorium reactors and whatnot.
Yeah, so let's pause a little bit. That was wonderfully dense, succinct. I liked it. I can see why your podcast is popular, but there's just a few things I want to pick apart. So one is that indeed incredibly efficient. Like as you say, 3 barrels, right? Powered the whole of Paris for however long. The positive of that is also the negative, right? You have this incredibly potent material, which, I mean, how long is that going to be considered wasteful? What's the half-life on
thousands of years?
Well, yes, if the long-term objective is just to leave it sitting there, but keep in mind, just because it's determined as waste by the politicians, it doesn't necessarily mean that there aren't useful materials that can be used for energy. Remember, France might be only able to get maybe 2 or 3 bites out of the apple, but that's still like 1, maybe 2% of the fuel in that rod. And again, the reason why even that, by a lot of engineers is considered inefficient is because you're trying to essentially reprocess solid waste to be used as solid fuel to generate energy. And the reason why solid fuels are just, bad all around, and why, I just don't particularly like them. And you don't even have to be a chemist to understand this, but you can mix a liquid, you can mix a gas. You cannot mix a solid unless you convert it into a liquid or a gas. And that's kind of what makes the molten salt reactor such a popular, technique is, first of all, you don't have to worry about the safety aspects. The whole, people worry about nuclear meltdowns where the fuel rods are actually melting through and there's all this. You don't have to worry about that because the fuel's already melted in a molten salt reactor. And because the fuel is in a liquid state, you could burn up 99% of that fuel in the reactor. The 1% that's left over is waste. And because you've burnt up most of the actinides in that process, instead of it being toxic for 10,000 years, you only really need to keep that kind of waste in geological isolation for maybe 3 centuries at best, which is still a long time, but in geological terms, it's not
way better, isn't it?
It's not astronomically large.
There's quite a funny point to make here, but there's a lot of discussions I've heard people talking about about, it's not just about storing the waste and storing it safely. It's about 1,000 years from now, are we still going to be here to be able to actually notice
so,
that? And
so this is what I've heard, right?
Yeah,
like, it's easy to talk in geological terms, but we're humans. And if you think back to 1,000 years ago, or think back to what was happening in the first week of January in America.
Yeah.
Like 1,000 years is a long time in our civilization.
So there was a discussion that went on about how do we mark this stuff in a way that somebody would always know that it's dangerous and you don't want to be juggling with lumps of uranium or digging this thing up. It was a very interesting concept. And like writing the discs on the Voyager probe. You know?
Yeah, and you could do that if you want, or I'm just of the camp that you should just consider it a resource and just burn it up. And we had Ed File of Elysium Industries. He's looking to build a molten chloride fast reactor that actually uses this stuff as fuel. And and I asked him, how efficient is your reactor? He's like, it doesn't matter if it's efficient. If I'm not as efficient as the other guys, it doesn't matter, because all I'm doing is I'm burning up waste. And that's good. I'm getting the idea is we're going to be getting paid to dispose of this stuff, as a toxic waste, but we're going to be producing electricity at the same time,
making a profit. Yes.
Yeah. So what I mean, at this particular stage, we don't have to be the most efficient technology. We already are by comparison to LWRs. But I mean, if we're burning waste, what does it matter?
Before we get too excited by the future and the next generation, let's talk about people's concerns and misgivings about nuclear as it has existed today. I think I'd be interested to actually go into if we did a mind experiment, right? So Finn, if you had to guess how many nuclear reactors had exploded in power plants, like what would your number be? And if you had to guess how many people had died from nuclear power since its inception, right? It'd be good to get a feel for that.
Yeah, I know, for example, it's way less than people who've died from coal and air pollution, right? Like way lower. I think it's probably, I would put a guess at like how many reactors. There's obviously Fukushima and Chernobyl, the famous ones. I reckon maybe like I reckon 10. And I reckon people who've died, I'll put it at like, I don't know, 50,000. Maybe that's really conservative. Is it way less or way more? Put me out my misery.
It's a little bit more.
In the last six decades, and I might be off by one or two people, but I believe the amount of people that have died or have been directly affiliated with a nuclear catastrophe, at least abroad or the entire world, and this is including Chernobyl, 3 Mile Island, Fukushima, it's about 54 people.
Oh wow! So I was way off.
No, because yes, I mean a lot of
people affected, maybe. Yeah.
Well, yeah, I mean when I think about a nuclear incident, I think of people who have died direct. I mean, first of all, the idea of a nuclear meltdown, it's such a rare occurrence that when the media covers it, it's like the biggest story that you could possibly talk about. Like, oh, we got an election. Fuck that. We're talking about there's a there's been a St. Onofre went super critical. The reactors melting down. That's a big story. And the fact that it doesn't happen that often, is one aspect. The other aspect is that I mean, by comparison to coal, I mean, tens of thousands of people die every year from coal-related instances, whether that's mining for coal-related accidents.
You get more radiation living near a coal plant than a nuclear plant.
Yeah.
Something I read in my research.
You do. And a lot of people don't realize this, but when you, and gas too, okay. There's less pollution related to natural gas than coal. I got to be a little fair when I talk about this, but it's the same.
So this has been part of my problem when I've read stuff that's like, let's compare it to coal. I'm like, that's a pretty low benchmark. Like if your benchmark is coal power, you're going to win.
Yeah. There's a good way they measure it. I think I've seen a lot of people measure it against terawatt hours. So it's deaths per terawatt hours. And I have funny if I have it on my second screen, but it's 25 deaths per terawatt hour for coal. So considering how much 25% of the world's generate coal, it's 0.07 deaths for nuclear per. So
that sounds about right.
And wow.
And again,
that's
that'd be
way safer than I thought it was. Even though I knew it as I'm sort of not an alarmist or anything. I thought it was
massive orders of magnitude difference.
And I need to know, our listeners will demand to know, how many superpowers have been made since nuclear's inception? How many superheroes do we have flying around?
Well, I was a little confused by the questions. Like, because I could talk about.
They kept the spiders separate from the reactors.
Smart.
We heeded the message.
Yeah. No, and you know, and going back to fossil fuels, a lot of people don't realize this, but when you frack a shale, that's how we get natural gas in this country, or when you're digging up coal, there's a lot of radon in there. Radon is a radioactive gas, and you know, unlike the nuclear industry, which has to take all of these superlative. You know, you got to have these 9-inch thick steel pressure vessels. You have to have it surrounded by, you know, steel reinforced concrete rebar and all this other stuff. I mean, the amount of radiation that you could get exposed to, you know, throughout your life, assuming you live or work at a nuclear power plant, it's like 0.0005% the amount of radiation more than you would have gotten had you just been like
less than a transatlantic flight. Yeah.
Well, this was it. My favorite statistic of all of this was after Fukushima, that they put detectors on a lot of people, right?
Yeah.
And the two big spikes are their flight, and then when they went through an X-ray machine at an embassy or whatever, like you don't see Fukushima.
Yeah.
But there's the deaths that I've quoted are from production of the actual raw material.
I've heard it is dangerous to mine, right? So there are cases of lung cancer with uranium miners.
Uranium's not much better though. It's still down in a deep hole, and there's lots of, you know, was it radon gas? It's not very nice.
Radon. There are all kinds of different things that you could get, but I mean, it depends on which country you're mining it from. If you're mining it from China, I have no idea what safety precautions that they're taking. Actually, to put it,
we have no idea how real those statistics are.
All right, so this is going to drive you nuts. So one thing that I talk about on my show is rare earth production, and you know, China is like the number one supplier. They're digging up all the heavies, they're digging up all the monazite deposits. When you dig monazite and you're processing these rare earth materials, there's a lot of thorium that's left over. And, you know, one of the reasons why we're not doing a lot of mining is because, you know, our Environmental Protection Agency has concerns about certain thresholds and, you know, what's acceptable and all this stuff. The Chinese don't worry about this. They basically separate the materials through through acid. And then once they've done that, they take the thorium and they put it in bags and they just leave it out in the desert, just baking in the sun. And people just deal with it with their bare hands. That's, you know, so if that's how they're dealing with their mining waste, and this is a nuclear fuel that we're talking about, thorium, I'd be very surprised on how they deal with uranium. From what I understand, most of what China gets is from Australia. And from what I hear, they actually do a pretty good job in terms of how they mine for uranium. And they actually probably, one could argue, has one of the safest mining operations on the planet. So
can they then use that thorium for their own nuclear reactors if they had them? Did they have them?
Yeah. They don't have them. They are working on them. I don't know where they are, just because I really just can't get much out of China these days. But they've been working on a molten salt reactor program since 2011. The program was started under Dr. Zheng Minghen of the Chinese Academy of Sciences. And a lot of the stuff that he pulled it from was from the old Oak Ridge papers. So he actually, they're doing two separate types of reactor. They're doing a salt cooled reactor that basically is just thorium and uranium and solid like triso fuel pebbles with a gas cooled system. And they're looking into a liquid fueled reactor, which is what the Oak Ridge guys were intending to build or mass produce back in the 1960s.
So is thorium the element in the compound that makes the salt? Like you have sodium chloride. Is thorium something the salt from the salt reactor? Is that what it means?
What it is? So thorium is basically just the nuclear fuel. So there's different types of nuclear fuels. There's plutonium, there's uranium, and then there's thorium. Thorium, you know, as you stated, it's a fertile nuclear material. So by itself, it can't just do fission on its own. You need to combine it with some other form of uranium, ideally uranium-233. You could use 235, which is another isotope of uranium, and that's the more common one that we use in today's.
Generally used in like water reactors now, isn't it? 235.
235. 235. Yeah. The natural uranium is 238. That's the stuff that's most common. The really rare stuff, the 235, that's the real fissile material that we were using. That again, and that's another reason why we were looking at breeder reactors. We wanted to try and find an efficient process that just used the natural stuff and bred 235 or plutonium as a result.
And 236 is the stuff we like to stick in the front of weapons and shoot at each other. Is that the one?
235.
236, sorry.
236. I don't know if I've never heard of anything using uranium 236. I've heard of plutonium 239, which is a isotope of plutonium, but I don't know if I've heard of. Yeah.
Well, so can we deep dive on that? Talk me through how you make a nuclear bomb. Obviously, leave out some of the key instructions.
We don't want to get into trouble for that.
I don't think. Well,
and China. We're still waiting for comment from you on a few of these issues. So one thing I'd like to know is
should we focus on how to make a nuclear bomb from nuclear byproducts in terms of nuclear power?
That's what I want to know.
Okay.
How interconnected is nuclear energy?
Yeah. Then I've got a good question for how do we do the reverse, right? Because I think a lot of people will be like, Russia got loads of nuclear bombs, America
that
too,
is happening. Right? I've heard that they're recycling old Soviet nukes.
Can that be done?
We've actually in the United States we have been doing that since the 1990s. When the Soviet Union fell, we actually bought up a bunch of during the START treaties. We actually were taking a bunch of Russian.
Good old capitalism, hey guys.
Well, I mean, this is the thing.
Not using those nukes, Uncle Sam will buy them.
We'll buy them back.
Well, I mean, if you think about it, I mean, you don't want to use it, for its original intended purpose. And I talk to a lot of anti-nukes who are like, you just want to take nuclear bombs and you want to just take the material and make and use the uranium to make electricity. I'm like, yes. That's exactly what you want to leave it in the
That's
bomb?
Great. What they saying that as a bad reason?
Well, I don't know.
That's
There's some people, some people I can talk to about this who know nothing about nuclear energy, and I'll tell them about this stuff, and they're like, "Wow, that's actually I did not know about that. That's pretty cool. I'm surprised that nobody ever told me this stuff." And then I'll just have people who are just so gung ho anti-nuke that you just can't talk to them. So good luck. I wish people the best of luck, but you're going to get people like that. Thankfully, I haven't really gotten a lot of those on my actual comment section on my podcast. I've actually gotten some pretty positive.
Fix that, don't worry.
But
I reckon there's probably quite a few people like that who listen to our podcast, but I reckon they're probably open to changing their opinion if we present a good case for why.
In my experience,
not?
the people commenting most prolifically don't listen to the podcast episodes. So
Right.
No reaching them.
Well, to answer Johnny's question about 5 or 6 minutes ago, because I actually heard it and I wanted to refer to that. So there's a lot of people who are like, and the other thing about thorium reactors, a thorium reactor is just any reactor that can use thorium. So a light water reactor could technically use thorium. There's just no constructive reason why you'd want to do that. The reason why you want to use thorium in a molten salt reactor is because because of the way thorium works, it just happens to breed better in a thermal molten salt breeder than anything else if you have the right materials. But you can run a molten salt reactor on uranium, you can run it on spent fuel, you can run it on plutonium. You can pretty much run it on anything. You're just melting the fuel and the solvents. But to answer Johnny's question, and the first misconception that I want to kind of answer here is there are a lot of these people that, the reason why we don't use thorium reactors is because the military-industrial complex wanted nuclear materials to make bombs.
That was literally the first thing I said to you in Reddit.
Yeah, and the answer to that question is, well, no, that's not at all why it got canceled. And if that was the reason, it's kind of a stupid reason, because the fact is that light water reactors don't produce weapons materials. There's a huge distinction between a commercial reactor and a research reactor. The first thing is enrichment. Typically in the United States, we don't enrich anything past maybe 3 or 4% uranium enrichment, and that's sufficient quality for running the fuel in the reactor to generate electricity. If you're talking about making a nuclear bomb using uranium, you need to enrich the uranium to like 90%. And you can do that in a research reactor, and you can do that through centrifuges and all that stuff. But the amount of energy and water and materials that you need to actually do that, it's so costly and labor intensive that it's actually pretty easy for most world governments to detect whether a country's doing it, whether it's Iran or China or, you know, whatever. So the whole thing.
Another myth I've heard: is it true they can detect from space whether someone's making a nuke?
I don't know that for sure. I don't know that for sure because I don't have contacts or anybody that I know of that works at the IAEA or in.
For the listeners here, if you make a nuke at home, let us know.
From what I understand, and I have a few friends of mine who work in the Defense Department, and I cannot say much other than if somebody's making a bomb and they're not supposed to be, we have tools to know whether or not they're doing it.
They say that with your TV license, don't they? And honestly,
they got two vans driving around.
The number of times I haven't owned a TV. So in England, you have to pay a fee to support nationalized television, a couple of channels.
Propaganda system.
I know it sounds terrible to Americans, but it keeps, the nature documentaries on the air, and so we don't have lots of ad commercials and
anyway,
and EastEnders. Yeah. No ads for British people, I might add. Everyone else in the world gets the ad.
In order to collect this, they have to constantly threaten you. We know if you're doing it. We know if you're watching TV without a license. We know if you're making nukes. Santa knows if you've been naughty or nice. And I'm starting to suspect it might just be a lie.
Yeah. I mean, it would work for me if it, I'm probably not going to try it. So you put me.
I actually did not know that you needed a license in the UK, but I'm learning something here. But yeah, so the best answer is I don't know. We hope that as the channel grows that we'll probably get some experts, and I'll bring up the fact that, hey, I was on this podcast. I have to ask you, how do you know if somebody's making nuclear materials? My only question is that Big Chris from Beyond Binary is thinking about making a nuclear bomb.
Is it? It wouldn't be the worst thing I've done in the last couple of years. It wouldn't be my worst idea. I'll put it that way.
Maybe they can't really go into it because if you say, "Oh, well, we just look for this and this," then they can kind of hide it, right? So it's a bit of a
you've got optical
topic,
telescopes. They could probably see everyone driving around and delivering the, don't touch the stickers. So it's going to be
my best guess. The simple answer is they probably can, because NASA does have space telescopes that can analyze various types
more than
of
just light. Yeah.
And we know that there are nuclear materials available on Mars, on the moon. So if we wanted to set up a Mars colony and just be completely self-sufficient and power the machines to terraform the planet, we could do that. We could mine thorium and uranium on Mars if we wanted to.
That's crazy. I didn't know there was that stuff on Mars. And there's water too, right? There's water too. So in theory, it should be.
We did a whole episode on actually not just powering a Mars colony, but why you'd want to do it. And the thing that's really interesting about Mars is that it has water, it has carbon, it has a 24-hour day. So if you're trying to adjust to a circadian rhythm, it's a really good planet to do that at. But it also has a really complex geological history. So it has on it all the resources that you would need to support a thriving technological civilization. We also talked about what are the kind of short-term economic gains to really doing that. And the short answer is there's not, but seeing as Elon Musk is really adamant about going to Mars and setting up a 1,000,000-person colony, if you're going to have people there working, doing work.
He's also brainstormed the idea of nuking Mars to terraform it quicker. Have you heard that theory?
Yeah, I've heard that. And yes, you can do that. I would probably argue that that's not the best strategy to go about terraforming Mars if you already have people on there. What you could do if you wanted to use nukes for terraforming, and this is actually probably my favorite thing is, and I'm gonna blow your guys' mind in the last 20 minutes, or I don't know how long we're doing this for. Actually,
mine's already blown already with all this stuff that you said.
No, Finn,
what?
no, you don't know what you can do with this stuff. So let me get into. So here's what I'm going to do. I'm going to talk about I'm going to talk about why the molten salt reactor was never adopted. I'm also going to talk about that if it does get adopted, which it seems like that's going to happen in the next 2 to 3 decades, what is going to really blow your guys' mind. So first of all, what really got, and this also to challenge a misconception that the military-industrial complex was responsible for shutting down the molten salt reactor. It's also complete bullshit. Can I say that on that?
Yeah, that's fine. Yeah,
Yeah.
Okay,
Please
fine.
do.
Awesome.
Yeah, please
Awesome. Wonderful. Fuck yes. Anyway, so it's actually the exact opposite. It was the military-industrial complex that actually got the molten salt reactor started. So what happened is back in the 1950s, we were just going full ham on nuclear power. So like the Navy had their reactor program.
with the help of some recently immigrated German scientists, right?
Well,
From Operation Paperclip.
they were, from what I understand, most of them were kind of focused on the space program and a bunch of other stuff. We already had we actually were way ahead of where the Nazis were in terms of nuclear development. We thought that they were ahead, but
Right.
you know, thanks to you guys backing up Norwegian commandos and blowing up one of the hydro dams that was
Yeah, that's such a crazy story, man. That the SAS trained the command like 50 Norwegian lads, and they blew up the heavy water dam to set the project back.
They did, and we didn't. We weren't really sure if they did. We were just kind of just running under the assumption that the Nazis are at either the same level that we're at, or they're ahead of us. In which case, we can't deviate. We just gotta whatever's on the table, we just got to do it. We got to get it done, and we just got to build it. And we were able to, within less than 3 years, we were able to get a bomb, and we were able to use it. And it's a really crazy story how the Manhattan Project kind of went on, and how secret they were able to keep it. But not to deviate too much, but once we did that, the Navy, they had their nuclear program. The Army had their nuclear program. They wanted to power remote facilities in places like Greenland and places where you just couldn't ship materials fairly regularly. And naturally, the Air Force wanted a reactor program. They're like, yeah, we want a nuclear powered bomber that could stay above the Arctic Circle for weeks at a time without ever having to refuel. And the guys at Oak Ridge National Labs, which worked on the Manhattan Project, they were listening to this and they're like, yeah, nuclear powered bomber. That is
Wait, did they make it or not?
They made a test one, yeah.
They made a test reactor, but cool. The funny thing about this is that the guys at Oak Ridge, when they heard about it, they're like, that is a really stupid idea, but the Air Force has a lot of money, and we have some really crazy ideas that we want to play around with. So we're going to
did it for the research money, yeah.
Did it for the research money, because the thing with the Air Force was, in order for you to build a nuclear reactor that could fit inside of an airplane and not kill the crew and give them cancer is you have to build it very light, and you have to build lighter materials, and you obviously can't have a pressurized water reactor like what the Navy uses for their aircraft carriers and their submarines. So they think, well, what's nice about a molten salt reactor is that you don't have to operate it at high pressures, so you don't have to have like really heavy lead or anything like that, so we can scale it down. And they built a test reactor in the 50s, but by the time they built a prototype, the Air Force had already mastered mid-air refueling, and we also had a really robust program for nuclear ICBMs, which again, thanks to the Germans, were able to help us out with that. But the research money was still there, so they're like, okay, well, they didn't want to use it for their plane. Could we apply this to a civilian reactor, and does it have some inherent safety features? Does it have any merit over what we're currently using right now? Because the nuclear industry was still very, very relatively new at the time. So they did this. It was called the MSRE. It was the molten salt reactor experiment. And it ran for about 22,000 hours between 1965 and 1969. And they did all kinds of experiments. They did random shutdowns. They scrammed it. They did all these different worst case scenarios. And one thing that they did, and you don't typically do this with a nuclear reactor, is what they loved about it the most. One of the things that the Oak Ridge guys talked about is you could shut the reactor down, have fun on the weekend, and then turn it back up again. Shutting down a nuclear reactor is a very labor intensive process. There's not just an off switch and then you could just go in there and work on the stuff. It takes a pretty long time for decay heat to stop happening and all that stuff.
Is one of the big reasons why we've got to have a very holistic approach to energy across
Mm-hmm.
whichever approach. You can't just go just renewables or just nuclear or just coal, because you got to have that base load, and nuclear don't scale up and down very quickly.
Exactly. Now, of course, the guys at Oak Ridge weren't thinking about what you could do with these process applications other than, oh, well, we could desalinate seawater. And of course, by the time they were thinking about commercializing it, it got shut down by the Nixon administration, not because it wasn't inherently safe, not because it wasn't, really good technology, but because everybody else was working on solid fuel, and they didn't want this to be the industry norm, because for them, it was like starting over. The other thing that really shut it down was the chairman of the Atomic Energy Commission was from Southern California. Southern Californian labs were working on, fast breeder reactors that use solid fuel and all that stuff. And because Nixon was a, politician from California, he was seduced by the fact, if we're going to spend any research dollars on any of these programs, it should all go to Southern California. So that's pretty much the reason why the MSRE was shut down. It wasn't until decades later that a lot of people started picking up these research materials. And Kirk Sorensen, who used to work as a NASA engineer, actually looked at this for powering a lunar base, among other things. And, got all the Oak Ridge papers, put them onto a PDF, put it on the internet. And there was just this really interesting renaissance and this like revisit to, hey, maybe we should go and do this. And in the last decade, we've seen multiple nuclear startups, but like over a dozen of them are like molten salt startups. And there's a reason for that. It's inherently safe. It operates at ambient pressures, in some cases below atmosphere. So if you're operating on Mars, you don't even have to pressurize it, which is pretty cool. It operates at extremely high temperatures. A typical light water reactor will probably run at about maybe 400 degrees C. A molten salt reactor will operate at 700 degrees C. And what you're left with is 650 degrees C process heat. You could do a lot of stuff with that. You could melt steel. You could make synthetic liquid fuels. You could desalinate seawater pretty much cost effectively, because that thermal energy is free. You could terraform a planet if you wanted to. One of the things that we talked about in the show is the idea of using a molten salt reactor and then having that process heat basically run a bunch of industrial processes and making like hydrofluorocarbons to basically heat up the atmosphere over a long period of time. I've always liked the idea of using it in a cogeneration plant. So basically taking like an old decommissioned coal-fired power station, which, a lot of people don't realize this. They only think of, it pollutes because it burns up all the stuff and the smoke goes into the air and it's bad. Well, that's part of it, yes. But again, you're burning solid material. And when you burn coal, there's a lot of ash that's left over. That ash usually sits in a big tailings in the middle of, a major populated area, and God forbid it leaches into the groundwater or goes into a major river. It'll inundate, thousands of acres of farmland and, various communities and stuff. So
isn't one of the large, one of the products that comes out of that ash thorium, funnily enough.
Yeah. So people don't believe me when I say this, but there's actually more energy content in the coal ash waste than there was in the coal that was burned to make that ash in the first place. Yeah. And when I tell people that, they kind of blow their mind. So my ideal application, my ideal use application is having a old coal plant, tearing out all the stuff, the steam turbines, the stuff, maybe reusing some stuff like the blast furnaces, have your electricity be generated by molten salt reactors. Ideally from the uranium and thorium that is in those ash tailings, just basically extract it through like maybe a plasma gasifier or something like that. That'll run your plant. And then with that process heat, take coal and make liquid fuels. What's nice about, we know how to make liquid fuels from coal. The reason we don't do it in most countries is because of the fact that it's a very inefficient process. But when you're already producing clean electricity and that waste heat is free, I can basically make liquid fuels really cheap, much cheaper than petroleum-based one, and much cleaner because I can do additional processing.
Yeah, as you say, when you're talking about the level of energy that these processes create, efficiency isn't really the most important factor to consider.
There's a couple of things, just problems with that. I just wanted to see if you thought about them. So one of the bigger things with nuclear is the fact that you've got to put it in a sensible place. It's got to have access to water, a lot of water. So it's whether a coal-fired flight is going to be close to enough water to do that.
So
reduces the number of sites that's going to be feasible with.
In most cases, yes, you're right, and in most cases, yes, it has to be. A molten salt reactor is actually one of those special use cases that it doesn't. The thing that's nice about the salt materials is that salts have a very high propensity for heat, and as a result of that, you don't really need. Actually, you need zero water for cooling in a molten salt reactor. The only reason you'd need water if you were using a molten salt reactor is if you wanted to use a steam turbine, like what Thorcon's talking about doing, just because, you know, there's already an industry around steam turbines. The more advanced applications, like what Flybe Energy is talking about, is they want to basically use supercritical CO2 to power what's referred to as a Brayton cycle turbine. And the reason why you'd want to do that is because you have that process heat available to where it'll actually work in the way that it was intended. And because of the fluid dynamics of supercritical CO2, the amount of space that a 300 megawatt steam turbine takes up is about the size of, you know, an average sized house in North America. That same turbine in a supercritical CO2 Brayton turbine will probably take up this desk that I'm currently sitting in front of right now. So there's a lot less space that's taken up. It's a lot more efficient. It's a lot more compact, and it doesn't require water either for cooling or for running the turbines. So the only reason why you'd want to have.
How does it then? Sorry if I missed it. How does it then generate electricity, or is it that's not its purpose? Is to generate heat?
How does the molten salt reactor generate electricity?
Yes, if it's not going to use water to drive a turbine, how is it going to generate electricity?
Well, Brayton cycle turbine is a turbine. It just uses a different material to actually spin it. It uses supercritical CO2 that's been superheated to the point where it's.
And that's a closed loop, so it doesn't need like a big pool. Okay, that's interesting.
No, yeah.
Because France, through I can't remember how many years ago, but one of the bigger problems France had recently, and they've got 50 something reactors. They actually had to shut down a large number of their reactors because they had a pool of water that is what they use to go to the turbine, and it turned out through a lot of hot summers that actually the lake or the water reservoir or whatever it was that was feeding the reactor was actually getting too hot. So much like a fridge, if you're running a fridge in a full warm house, it's going to struggle. They actually had to shut the reactor down because the lake was heating up, so they couldn't actually run it anymore. Yet
another reason why I just hate using the idea of using water for cooling, and I know that that's the way we run most industrial processes, but that's another reason why the molten salt reactor is so good, is that you don't need water for cooling, either for industrial processes or whatever. I mean, it's nice to be located, but you know, to your point, if we're using this in my ideal scenario, basically just recycling like 150 years worth of coal ash tailings and, you know, cleaning up, you know, that and using it as a resource.
So is this a good time to pivot the question then and ask the $1 million question and say, well, okay, if it's been around since the 50s and it's going to be the future, why are we, you know, 70 years later still not got
Alice in Wonderland, the Queen of Hearts, like jam yesterday, jam tomorrow, but never jam today?
Why have we still got no molten, you know, Gen 4 reactors or molten salt reactors?
Great question. So turning the clock back on, turning the clock back on the clock. We're at 2021. If we're going back to the early 1970s, that's right around the time that the MSRE experiment got shut down by the Nixon administration.
Go back in time and kill Nixon. Got it. All right.
I don't think that
I'm ahead of you, brother.
I mean, if you ask me, I mean, he's probably one of the worst presidents that we've ever had, and I can list. I got a whole document that goes off. I don't know if I'm going to discuss that in the future.
God, that's a hard list to compile, isn't it?
Yeah. Not really. And if you look at all the stuff that he did,
it's a new country. It's less than 50, and technically, all presidents are in the top 50 presidents.
This sounds like material for a whole.
I've only got to get rid of a few.
Yeah, if you want to have me back on to talk about why Nixon sucked, I'm happy. I'm happy to do that. But no, I mean, this was the 1970s, but nuclear was still, you know, being considered by a number of nations. France, that's right around the time they started going full ham on nuclear power. But right around the mid to late 70s, that's when, at least in this country, in the United States, where the whole anti-nuke movement started happening. That's like right where we had 3 Mile Island. People were starting to question whether nuclear power was safe. There were a lot of misinformation programs. A lot of them were funded by specific interest in the fossil fuel industry. So, so that's one aspect.
So it's political will was one of them.
Political will is one of them. A lot of that is fueled by, reason why I wanted to do this podcast with you guys is misconceptions about nuclear power. What's really changed in the last couple of decades is the advent of the internet, and a lot more people are starting to get sort of educated on their own to learn that, well, nuclear power isn't exactly dangerous, and maybe the concerns that our parents had back in the 70s aren't necessarily warranted now. And even if they were, there are newer technologies that are being developed by several private interests and in several countries that have more inherent safety benefits than what a traditional, reactor does today.
It's a bit like, just quickly, it's a bit like a naming thing, isn't it? Because we talk about nuclear power, but just listening from you to you this evening, it's like there's so many different types that, like, it seems like nuclear power has kind of been smeared. And then, like, these subtypes seem actually really promising. So maybe it's like a little bit of a branding thing.
There's so many different flavors.
But there's a lot of variables, it seems, right?
Yeah.
From what you guys have been saying.
And Finn, that is one big issue that we have on our podcast, is that there's like 1,000 different ways to do nuclear. And as soon as you start talking about molten salt reactors, well, you just open up like 3 to 6 different channels of how you could do that, because you could do
loads of different types.
Fast breeders, Thorcon, which is looking to build a reactor in Indonesia. They're just looking to do a straight up burner reactor where it just burns the material. So there's a lot of different ways to do nuclear, and once you get into the molten salt reactor, that just gets exponentially higher. The biggest issue.
Let me interrupt, because I think it'll build on to what you're saying. So one of the more nuanced takedowns I've heard from the green movement is that we need to, stop making CO2 now. There's a big crisis, and we have solar and wind now, and all these theoretical future nuclear plants. They'll take a while of research and development. They'll take a long time to cut through the red tape and get approval. And I think it's a problem with a false dichotomy, right? Should we use this or this? Well, why not both? Obviously, coal is shit. Why are we still using coal?
It's cheap. That's the thing. It's cheap. And it's subsidized.
It's cheap. And in North America alone, there's more chemical energy in coal than there is in all of the oil reserves that are known or technically recoverable today, which is one reason why I look at coal as possibly a resource that we could use. The other reason I look at coal is because we have established industries here, and rather do what we tried to do back in the 1970s. We're saying nuclear power is great. It's 1,000,000 times more energy dense. That's not going to win a lot of favor with the fossil fuel industry that thinks that, our livelihoods are in the line. But if I come in, and that's another reason.
Yeah, like your idea to piggyback on the coal plant. So the coal plant's still involved. There's people still have jobs.
It'll still something like that will still have to be. So there's 3 different types of energy you need to power a nation. So you need the base load, so something that's always generating a certain amount of energy. You need something that can react fast, because as we always say,
mornings on the way to the commute, and
exactly. So it's sort of the analogy in the UK. I'm not sure if it's the same in America, but every single time the adverts come on in EastEnders, so the adverts come on a soap, and
turns
the kettle on. But and then 1 kilowatt per house suddenly jumps up. So you've got something that's going to react fast, and coal and gas, other things, they react fast. And then you've got the the third renewables that can sit on top and just take away from everything else, that peak shave a little bit that's there. And nuclear is a good option for that first one, that firm level. And unfortunately, gas and coal are good for fast reacting. As we said earlier, nuclear don't react very fast, but although liquid salt reactors.
Well, the liquid core stuff, the molten salt reactor, what's great about that is it kind of addresses 2 of those. It addresses the electrical energy, it addresses thermal energy for industrial process applications. And that's something that a lot of people that says get rid of CO2 now, they don't account for the fact that not everything is electricity. You're not accounting for thermal energy that's required to smelt an aluminum plant or steel or all the stuff that we rely on. And there are some people like, well, just let China deal with that. So, well, how are they going to do it? I mean, they got to do the same thing. They got to burn coal to make the steel, to make the aluminum, to make all the other stuff. So I just argue that if I have an energy source that can do a better job in smelting aluminum and produce electricity at the same time, as well as do all this other stuff, we should do that. Now, with renewables, I'm not anti-renewables by any stretch of the imagination. They definitely have a place. My producer lives kind of like off the grid. She lives in kind of like a little off-grid little dwelling. She's looking at solar herself. For
I've got
certain
13 panels on my roof. I'm very happy with
Well,
them.
there you go. There you go.
So we use ours to heat our water tank. So anything
Mhm.
that's above what we use, it heats
Sure.
our water tank. So it just
Now-
In places like
Yeah.
California, Australia, South Africa, it's a brilliant
Yeah.
solution.
So I've
Spain
actually,
too.
so when I initially moved out here to California, I've lived out here for about 5 years, but I actually started out working in the renewables industry, and my job was getting homeowners qualified for various programs to where they could actually afford to get solar. And I'm glad I did that, because in the time that I worked at that company, all of my misconceptions about solar energy were basically fixed. We're basically just, I learned a lot very quickly, and I learned how the industry worked. I learned how the subsidies work. I learned how the government responds to solar. And I also realized that if you want to do 100% Green New Deal, solar and wind, you just can't do it, because there are there's intermittency issues. And two, solar and wind is very diffuse. And three, even if it wasn't, the only solution you're resolving is electricity. That doesn't resolve the other 75% of the energy spectrum that's not electricity based. It's thermal, it's chemical, it's whatever. We're writing an episode right now that's talking about electric cars. And I love electric cars, but one of the reasons why I advocate for synthetic fuels to kind of come into the mix is because if you want to go 100%, EVs, 100% electric vehicles, you're going to have to basically double, or in some case triple, the amount of electricity that you're producing in your country. So I don't think that we, as of right now, we have the industrial capacity anywhere, maybe China, but not in the United States, to build 3 times as many power plants that are dense enough to really meet that energy demand. The good news, and actually we covered an episode about your guys' country, Moltex, which is based in the UK. They're building what they're referring to as a stable salt reactor, which basically is designed to run on a number of fuels, but their first generation reactor will run on spent waste. And what they're doing is they're talking about generating about 1 gigawatt of power from said waste. And then they're also using molten salts as a storage solution, basically storing that excess thermal heat and releasing like another 3 gigawatts over an 8-hour period as a backup for renewables. So that's another thing that I like to talk about too, is that molten salt reactors can actually work in synergy with solar and wind as not just a backup power source, but as a load following tool. One of the other issues is that, when the wind shuts down or the sun isn't shining as much, most power plants don't do a really good job following the load. In Southern California here, we have a lot of solar, and that's great in the summertime, but when the load's not enough or not sufficient enough to meet all of our energy needs, that all kind of comes in through these, what we call them peaker plants. Basically, they're just standby natural gas generators that are just sitting there until the load dips down and they just turn the generators on and they generate electricity.
Almost instant,
almost instantly, and that's great. But the problem is these are direct cycle turbines, and they're not as energy efficient as the more advanced combined cycle ones. So they're burning probably twice as much fuel and generating twice as much emissions than you would need to meet that need. And at that point, I'm just thinking, wouldn't it be better to just buy combined cycle plants and just do 100% of your electricity through natural gas? Sure, but
it just makes it's not cost effective, is it? That's what they were looking for. And the cost factor and the solar factor brings us back to another question that might lead us on to another problem with nuclear. So solar's been through a paradigm shift in the last 10 years. It's gone almost close to 100% drop in price, like 90% drop in price, which is mad. And it's going to bottom out somewhere. And there's loads of problems with recycling, but we're not going to go into that now. But over the last 10 years, gas has gone down in price. Coal has gone down in price. This is over the whole chain. This is from manufacturing to actually giving us generation. Geothermal's gone up a little bit. Solar towers have gone down a little bit. One of the only ones that's gone up in price is nuclear. And there's a thing that they call
Why is that?
I was going to ask our expert, but there's something
Sure.
called learning time, basically. So when you're developing something for a period of time, you expect it to kind of start curving down as you learn more about it and get more efficient. Nuclear is the only one that's been curving the other direction, and I've looked and I can't find why. So I was wondering if you might.
And I've been studying this for well over a decade. So what you're referring to is in what we call in economics the learning curve ratio in manufacturing.
That's
so
exactly
when you produce a lot of something, whether it's reactors or solar panels, eventually you get so good at it that it becomes more cost effective, and you've already done the tooling and stuff. So the reason why that hasn't happened in nuclear is a couple of reasons. One, nuclear power, at least in this country, it is highly regulated. It's a very regulated industry. You can't just go and say, hey, we need some electricity, I'm going to go build a nuclear power plant tomorrow. It's not that simple. Even if you're going with NRC guidelines and everything that they do is light water reactor, base, it takes well over a decade to get an approval for a light water reactor. And then once you do that, it's extremely capital intensive because of the materials that you need for said reactor. So you need a 9-inch thick steel pressure vessel, which unfortunately there's only one company that I know of that actually makes those things anymore, and that's Japan Steelworks in Japan. And China, I'm sure, has their own, but right now that's really fitting their own demand for nuclear power. They're going crazy and building like 50 reactors in the next 3 decades, which is wild. And the other, and
we'll come back to that point because that needs to happen. But carry on. Sorry.
Yeah, no, I mean the reason, the simple answer is the reason why it isn't happening is it's regulatory based. When you have a lot of regulations surrounding nuclear power, you're not going to be able to build it. Now, a lot of the points that I made here about the molten salt reactor fixes a lot of those issues. That it doesn't operate at high pressures. You don't need those pressure vessels. It's liquid based, so you're burning up most of the fuel. It has a lot more inherent safety benefits than a light water reactor. The problem in my country specifically is that our regulatory code is all based on the light water reactor. And since the Omnibus Act in 1990, the NRC is a 100% cost recovery organization. Just to kind of go into a little bit of why that's a big deal is generally you think that all government agencies are funded by the government. In the United States, the NRC is an exception to that. They don't make their money from the taxpayers. They make their money off of licensing fees from existing reactors. And if you want to build a new reactor or change the regulatory code, private companies have to engage with the regulators at the going rate of $270 per hour. So it is not an inexpensive thing to do any kind of business with the NRC. And it's this chicken before the egg scenario. For them, it's like, yeah, we'd like to give you a license for a molten salt reactor, but we don't know how a molten salt reactor works. Oh, that's fine. I want to show you how it works. Yeah, we'd like you to show us how it works, but we don't know how it works. Right. I want to build a reactor to demonstrate its abilities. Right. But you need a license to do that. Okay. Give me a license. Well, I can't give you a license because I don't know how it works. So that's
sounds like
why is that the case?
Nightmare.
Yeah. Why is that bureaucratic system? I mean, that's just crazy, right?
You're right. It is
a company that makes money from selling the current solutions.
Yeah.
They've got a monopoly. They don't want to change.
I guess. But then what about other countries? Other countries must not have that same restriction, right?
From what I understand, Canada doesn't.
There's good reasons why nuclear is, well legislated. There's a few countries which America would rather not have a nuclear program.
Yeah, I mean, look, there are a lot of problems. There are a lot of regulatory issues that we have to do. I actually did a Christmas episode where we talked about the 5 things that the U.S. needs to do in order to change that, and it got some really positive reviews. And I actually had some people that said, hey, I actually want to send this to my congressional representatives. Can you just kind of outline this for me so I could send it to them so that we could push for this in the next cycle? I'm like, yeah, absolutely. So there are solutions. There is a way we can fix it. But yeah, Johnny, to your point, the reason why that hasn't happened is completely regulatory. If it was operating under the free market, if we had a regulatory license structure to where we could get licenses to build molten salt reactors, at least in this country, then we would have an economic case to where we could mass produce these reactors on an assembly line to the point where we could sell these things cheaper than gas turbines. And that's the other thing I haven't talked about in terms of costs. If you're able to operate it at the cost estimates that a lot of these companies have talked about, I've heard as many as estimates as probably like about $2,000 per kilowatt. to put that into perspective, to build a nuclear power plant in the United States is about 4 times as expensive. So we're talking about a fraction of the cost of conventional nuclear, and compared to coal and gas, it's about half as much. So when you produce the cheapest option, I mean, that's essentially the source that everyone's going to go with.
So to summarize, we're waiting for the American political machine to break up a very powerful and rich lobby. I won't hold my breath. Got it.
So, yeah.
But then, look, what if it happens in other countries first, right? Like you were going to, Sean, you were going to talk about Canada and maybe other countries. If they start doing it, America might then change their policy, right?
So Moltex right now, which is a UK-based company, they already are. They already have a memorandum of understanding as well as some agreements with the Canadian government. They're going to be actually co-locating one of their reactors to an existing light water reactor, and it is essentially going to be powered by the waste energy from that plant, while also producing excess energy as a backup for renewables. So,
and when you say it's going to be, what's the time frame for this? Like 5 years, 10 years?
My understanding is that they should have license approval within 5. They should have the reactor up and running within 10 years.
And that 10-year framework is what I see as one of the bigger problems. Is we've been through the costs, we've been through the fact that it's safer generally, which is another thing I'll come back to in a minute. We've gone through locating them all, but then you've said that Japan's going to build 50 reactors or so. China's going to 50 reactors in the next 3 decades. Yeah. And you say it takes 5 years to agree that, yes, we can build it here. Then it takes 6 to 12 or more just to commission the site. I mean, if we're going to turn this on quickly before some climate goal in 2040 to reduce carbon emissions, we've really got to hurry the fuck up. It's gonna, you've got to be done tomorrow to kind of start this going.
100%. And I mean, again, could we do it tomorrow? We could. I mean, again, a lot of the reason why it's taking so long is there's a regulatory process, there's an approval process, and for good reasons. I don't want someone to just build this thing in their basement and have Chris go to jail because he didn't know what the hell he was doing. But
bam, there goes my weekend plans.
but no, I mean, in other places, it's being done much quicker. Thorcon might end up having one of their reactors up and running within the next 5 years. If we're talking about going back in time to when we started experimenting this stuff through the government, like Camp Century, we built a nuclear reactor in Greenland to power a military facility.
Operation, was it Frostworm?
Iceworm, Project
Iceworm. There we go.
Yeah, so Project Iceworm, the whole concept between that was the Army's first implementation of a portable nuclear reactor to operate a remote outpost in the Arctic. And they had it up and running from conception to implementation. They had it up and running in about 2 years. So, there are people that make the argument that, hey, if it's going to take 10 years, we shouldn't be wasting our time. It can be done faster, but a lot of things have, and you're right, a lot of things have to change, so, and that's something that we talk about, pretty passionately on this channel. And
it needs to be something that needs expanded more, because looking into it a little bit further, that if you imagine the subsidies that are currently, and this is currently a few years ago, I think coal, fossil fuels are subsidized. They take up 70% of the world's subsidies in terms of energy. And then renewables take up 26%. And there's a chunk in the middle, a very, very small chunk of a few percent that's nuclear. And there is the International for Renewable Energy National Association or something. There's a group of people that monitor all this type of stuff, and they're projecting through looking at countries that's not going to increase through nuclear at all for the next up to 2030. So I think it's 6% 2030, and 2050 it's 4%. So there's they're not seeing any political will there anyway. The subsidies and coal and fossil fuels and everything else decreasing massively, and renewables increasing, but still there's no base load subsidy there at all. Now either nuclear's got it sorted anyway and it's fine, it's going to be reasonably cheap enough, but you would have thought there would have been some push, and I just don't understand it.
I mean, you could go back, and Lord knows I've gone back and just thought, if I had a time machine, if I could go back and if I could influence a handful of individuals to change certain things before the anti-nukes had an opportunity to really just sort of just decredit the industry, we might have been where we were in, where France is. France, I always use France as an example. These guys, back when the oil shocks happened in the 1970s, and there were the embargoes, they were really concerned because they were getting most of their electricity from imported oil. They didn't have domestic coal reserves. They didn't want to be reliant on the Russians in terms of natural gas. They figured, well, we're France. What the hell do we have? It's like, well, we got some smart people. What if we just, had a really robust program to where we just did nuclear energy? And it took a long time, but within 3 decades, they got to the point where 3/4 of their electricity comes from nuclear power. And
I think a good percentage of English power comes from France's nuclear power.
But
yeah,
I don't. To be honest, I understand the anti-nuke argument. To be honest, because if you've just been through Hiroshima and Nagasaki and you didn't trust your government because they were pushing into Vietnam and Korean War and stuff, I get exactly where they're coming from. So as much as I agree that we could possibly go back in time, I just still think that the will from the people we'd still be in the same situation.
A big problem you have with this as well is NIMBYism, right? Like everyone likes the idea of a nuclear plant. Oh, brilliant! Yeah, thorium reactor. Please do that. In Canada, you said, let us know how that experiment goes. Wish you luck.
And you're absolutely right. And that's kind of one of the reasons why I advocate, and I get so much flack on this, because what you guys got to understand is the second I start talking about this stuff, and I didn't know how people were going to respond to this when I started talking about this on my channel, but I get so many comments from all kinds of different people. And, you'd think, oh, is it mostly people from the left? Is it people from the right? It's like, well, some of my favorite comments, I have a guy who identifies as a humanist socialist, and I have another guy who is an alt-right conservative who's like pro-Trump. So what's interesting is I seem to have found a formula on my channel to where I seem to have been able to track both extremes from the political spectrum. So
in a positive manner, I hope.
And I'm very much so. I mean, yeah, occasionally I'll get those weird comments from people who that the reason why the molten salt reactor was never adopted was because of a Nazi conspiracy. I'm like, how do I respond to that? I don't think I'm going to.
Me and Johnny have had fun this week arguing with someone in the comments who, as I predicted, and I called him, I was like, I bet he hasn't listened to the episode he's commenting on right now. And sure enough, the next thing he said is, I don't listen to that shit.
Amazing. Yeah.
So
trapped him into it.
We actually have gotten a couple of emails from different people, and the funny thing is when we have people come on the show, people ask me, how did you get Ed File on your show? How did you get Lars Jorgensen from Copenhagen? It's like, that's the funny thing. They called us. They watched our channel and they're like, can we come on your show and can we talk about, because we're also doing waste burning reactors. Can we talk about your stuff? We've also heard from people like in the Thorium Energy Alliance who are like, I've never heard of your channel before, but I like it because you guys are talking about process applications. We've talked about it, but we've never really talked about how that could apply. And that's really where we found our niche and our success, in that we're not just saying, oh, nuclear is great, it's awesome, and these are the technologies, and here that is. We talk about them, but we also discuss when you have X, this is what you can do with X, and it's amazing. It's like, you can make desalinated water, but you can also terraform whole planets,
And I think that's the joy. A lot of people in these spaces are talking heads, sometimes for a lobby, sometimes spokesperson for a company. And when you have someone such as yourself that's like intellectually curious and exploring, and I presume you're not about to sell me a thorium reactor, so you don't have anything to shill right now.
No,
and that's the perfect position to be, as you say, like just intellectually rigorous, talking to people with an open mind and hear the different perspectives, right?
Sure. He did say but though.
Okay.
Well, okay. So the funny thing is, one of the more recent interviews that we did, this guy actually sells some of his products on Amazon, and I'm like, which products? Like, well, we have a molten salt test. Basically, it's a salt loop so that universities and private companies that want to experiment with molten salt reactors, they can basically buy it on Amazon.
On Amazon.
Yeah, for about if you have
how much is it?
It's about $88,000 US, and I'll send you the link if you want. If
is it a referral link?
Yeah, you might. That's the thing. He's like, yeah, we sell it, but no one's actually bought it. When anytime that we've actually sold, it, it's actually been through like a university or like a company or whatever that's like done it, and we'll just make it for them and we'll sell it to them. And I'm like, well, why would you sell this? Why would you say, oh, because there's a number of companies and there's not a lot of companies that build these specialized materials that could, deal with hot salts at 700 degrees C and not corrode and not do this stuff. So this machine is just, you don't superheat it through fission. It's externally heated through electricity, but it allows universities and allows people who are interested in the science to work on it. And I'm just saying, well, if we have you on our show, can I get a discount? I'm like, no.
You want a referral code, right? And if they put Sean Kenny in the referral link, you get 10% of all purchases.
but it was great having him on because it just showed me like you have a really interesting approach, because where a lot of these guys are saying, well, we have a reactor and this reactor is going to work, and one day we'll get the money that we need to build this reactor. These guys are like, no, we're just going to go and build it, and that's what they've done in Denmark. They're basically just building the components, they're testing it, and they're like, and they've gotten interest from some people. It's like, hey, if we were to build one, could we buy some of your stuff? And like, yeah. So they want to build a reactor. That's their end goal. But in the meantime, they're basically going to be making money off of selling various components to build this. So once this becomes a, full-fledged industry, they're going to be in a pretty good place, from the market perspective.
That brings me back to actually another quick question that is a big problem with the current Gen 2 reactors, is the fact that if we wanted to scale up the number of reactors, they use actually, the supply chain's almost there for them, but it's more the actual just base, raw, hard to get rare earth materials they needed. Is that still a problem with molten salt in the terms of?
No, actually quite the opposite. So first of all, from my understanding, the actual materials needed, they're not rare earth materials. They don't need any like hardcore electronics or anything like that. It's really just things like Hastelloy, which can be made. I mean, we've made it in this country. We actually had an industry behind it because we thought we were going to be mass producing it, but that's not really a challenge from us from a regulatory standpoint. It's really just there really isn't a market for it because nobody's really heating up these molten fluoride salt solutions at 700 degrees C through fission or through any other external means. So it really is just that there isn't a market for it yet. But again, once you start having these companies get proper funding and the proper licensing that they need to actually go and build these things, the supply chain and everything else will come. And to your point from earlier, once this becomes an industry where you can mass produce these things in mass, it's going to get really easy for these things to drop significantly in price. Like I just gave you a quote for $2,000 per kilowatt, and that's from Multex. That's from the company located within your shores. They might easily be able to bring that down by 50% once they produce 1,000 or so reactors.
I think funding's key though. And you mentioned, more free market. And again, with all of these things, I don't want to implement a false dichotomy on it. I think part of the problem here as well is the funding issue. And I don't think the private market has the hunger to fund. So you want to make a new type of nuclear power plant, and when's the payoff? Because they could just throw that money at software and get it back in 2 years, right?
So according to Third Way, which is a third-party centrist think tank in terms of looking at various political issues, they've actually done a study on this, and in the last 5 or 6 years, about 1.3, almost $1.4 billion in private investment has gone to advanced nuclear startups in this country, not abroad, but in the United States. So there is a market and there is some interest, but usually the initial startup money is just to fund like small scale science and stuff like that. What's really encouraging, and I didn't get to close off with this, but in the last couple of years, we've seen a lot of different pieces of legislation being pushed through during the Trump administration, one of which was an advanced nuclear bill that has earmarked and appropriated about $4 billion to go towards advanced nuclear development through the Department of Energy. And there's already been a disbursement of about $160 million that went to 2 companies. One's a company called TerraPower that's building fast reactors, but they're using a molten salt storage solution to store excess power from the waste heat. The other one's X Energy, which is a gas cooled reactor that uses TRISO fuel. None of them are molten salt reactors by any stretch, but the fact that there is government interest, there is government funding going into this country. One thing that I've also talked about, and I don't know if it'll happen in the near term, hopefully, the next administration looks into it, but we have a $30 billion fund in the Department of Energy that has been collected through various nuclear plants across the U.S. over the last 2 decades. The purpose of this fund was to fund Yucca Mountain to store nuclear waste. Yeah. And when that got shut down, they basically just kept collecting these fees. And there's been some legal issues like, well, we don't want to keep paying it if you guys are just not going to spend it for its intended use. So one thing that we talked about, and probably what got us a lot of attention from the waste burner guys, is that I'm advocating that, yeah, if you have $30 billion, why don't you just give it to Ed File at Elysium, or give it to those guys at Moltex? They're building waste burning reactors, or they're looking to build waste burning reactors. Just give them the money and let them do it.
Technically being used for the thing they said it would be.
Yeah, right. Yeah. I mean, that's perfect. Yeah. That's build
recycle it rather than bury it, right?
Yeah. I mean, why? And this is what's crazy. I actually, when we had Ed File on the show, I actually asked him, so how much of this stuff, how long will this stuff last us for? Just like in the United States, like, well, if we're talking about just replacing every power plant in the United States with with one of these plants, about 320 years. That's just if we're talking about electricity. If we're talking about everything else, so replacing all industrial use applications, all chemical, all thermal, maybe about 80. But that's all coming from waste materials. And right now we have enough to take up a football field if we keep those light water reactors on and keep producing waste. By 2050, it'll be twice as much. So
I've seen stats that say if we're looking at thorium to the same level or higher to replace a lot of coal and firm level coverage, that this isn't a 300-year, but it's a 1,000-year plan. There's enough thorium, and it's more abundant in its ore, which I can't remember the name of, but it's more abundant than uranium is when you mine it from its ore, and it's also a lot safer to mine because you generally do it in a large pit rather than a big hole. So it's a long-term plan, thorium, rather than just
considerably. And you could probably go even further than that. Actually, from some of the estimates I've heard, it's actually closer to millions of years if you're applying it into a molten salt reactor. The reason for that is that the reason why we live on this beautiful green planet is because we have large amounts of uranium and thorium in the Earth's crust that is just decaying heat and keeping our core molten and keeping this giant electromagnetic field from having our atmosphere stripped away from solar winds. If we didn't have that, if we didn't have thorium, we wouldn't be here having this podcast right now. But seeing as we do, I'm just advocating, let's get a little bit of it and let's run our industrial applications with it and, maybe save the planet.
What a lovely vision. Thank you so much, Sean. I think
of course
that was brilliant. And what you did really well was tie together all the strands. You have a wonderful ability to be like 8 minutes ago when you went off on that tangent. I'm going to tie those 2 points together.
Yeah, and I've never done an interview with 3 different people. Usually I've done like one-on-one stuff. So this was great. I had a lot of fun. And
you held court, brother. That was amazing. Thank you so much.
Thank you, sir.
Can I finish with a final question? Like I'm quite interested in pragmatics, and I think we are here too. And what can everyday people do? Do you know what I mean? Because it seems quite abstract. You're very knowledgeable. Yeah. What can I do to sort of further this, like the thorium reactors, the molten salt reactors? That's really interesting. Should we be writing to people? What can we do?
Sure. So I'll be completely honest. I don't have the greatest deal of knowledge on how the UK government works. Like, I don't know if you.
It doesn't at the moment.
Okay.
Yeah. Just forget that.
So I mean, you could always write to your MPs, and I get that question a lot. So what I do is I'm going to keep producing content, and where we're talking about this applications, and we're talking about like real solutions that can be applied to this issue. And to Johnny's point, like, why have we done it? It's because You know, a lot of people aren't really knowing about this stuff and they don't have a lot of will. The second you start talking about all these really great things that you could do with these process applications, people get really interested. And then all of a sudden you start having people talk about it. We had 2 presidential candidates talking about thorium reactors, not advanced nuclear, specifically thorium reactors. One of them was Andrew Yang.
I was going to guess, obviously.
Yeah, Yang for sure.
And
who was the other one?
Cory Booker, who is a senator from New Jersey. But we've actually had some Republicans talk about it in previous elections. I believe John Kasich, who was a former governor of Ohio, also talked about it too. But
one of the more moderate Republicans, I think Cory Booker is Rosario Dawes' husband. I'm getting distracted.
Oh no, I didn't know. I don't follow a lot of celebrity gossip and stuff like that. That's you know. So is she?
Yeah, Rosario Dawson's.
Oh my God, I didn't know that.
Husband's Cory Booker. Yeah.
Okay.
What about my final thought was just what about philanthropists? Because you know, like Bill Gates is doing like his foundation with his wife, and they're looking into like obviously vaccinations, curable diseases, these kind of things. They're obviously a very pressing short-term thing, but obviously they're going to be thinking about longer-term things, right? So would it make sense to write to people like that, write to different philanthropists?
Yeah,
are there any websites?
Nuclear has a bad name.
Yeah,
right? Like it's going to be hard to get someone to attach their name to it, other than Elon Musk, who's a bit mad.
But who knows? Maybe like if Bill Gates sees the sense of it and then goes, well, why not? Why wouldn't he?
To answer your question, Finn, Bill Gates has actually already had one of those companies that got the $80 million fund. That's TerraPower. That's Bill Gates's company. So he's well aware.
Yeah.
So he's actually
well aware of it. Okay,
he's
that's
well
good to
aware
know.
of it, and he's
Yeah.
working on it. I have some disagreements on the way he's going about it, but at the end of the day, you know, we need more nuclear, not less. And you know, if you can do a better job than the light water reactor, I will be, you know, pleasantly happy. But the short answer is what regular people can do. Keep watching stuff like this. Keep watching your podcast. You know, watch my podcast, you know, with Sean Kenny at YouTube. There's a bunch of other people that have some really engaging content. If you're really interested in this stuff, I would share as much of this content as much as possible. One thing that my producer and I are going to be doing in the future is we're going to be coming up with some really engaging educational resources just for, you know, people like you guys, and for everybody that we engage with, and for people to share with their politicians, their congressmen, their MPs, you know, however their system of government works, we'll be able to provide them with these educational resources. And that's just something that
would be so good.
I've heard from Neil deGrasse Tyson that they're about to finally have a cabinet minister in America responsible for science. And he was like, that should have been done hundreds of years ago, but that's a pretty exciting development, right?
Yeah, and I know that Andrew Yang, I mean, not to deviate here, but I know that Andrew Yang, you know, he was talking about setting up a Department of Technology as one of his campaign promises. And one of the things that he talked about that, yeah, if I were to get a cabinet position under Joe Biden's presidential administration, it would be the Secretary of the Department of Technology. Now, I don't believe that they would be focusing on the nuclear stuff. That kind of falls into the DOE's territory. But yeah, I mean, we're probably going to be seeing a lot more politicians in the future. I mean, look, I'm 33 years old. You know, I have people that are in my age bracket that are elected officials right now. And so these people are very aware of, you know, what's going on. You know, we have less people denying that, you know, climate change is a thing. There might be some arguments as to where carbon emissions fall into that. But at the end of the day, we don't want to live in a polluted hellscape like, you know, downtown, you know, Beijing or Shanghai or anything like that. And I feel like getting nuclear involved in that discussion is one way to help. You know, we could look at carbon capture and other stuff. Actually, that's another application I didn't talk about is, you know, using nuclear to make jet fuel from carbon, just sucking it out of the air. The Navy's also talking about doing it out of seawater, if you can believe that.
Yeah, I've got about 8 more topics and questions I'd love to
Let's
go through.
do part 2.
It could be
I got all. Hey, look, I got all day. If you want to keep me on the record here, I got no plans for today. I'm stuck in my apartment, you know, because of COVID. If you want to keep this going, you know, I'm.
This is why we've never found it easier to get amazingly well-informed and interesting guests, because everyone's stuck at home. They have no excuses, nothing better to be doing.
You know what I'd love to do is like an episode where we talk about potential future technologies. That would be awesome. So maybe we could bring some of the molten reactor stuff and some of these new processes into
the more
an episode like that. Would be great. Yeah, that'd be so cool. A bit more like what if kind of thing.
Yeah,
but this all seems really feasible. That's cool. Yeah.
Well, my favorite, one of my favorite applications, and I'm surprised I just didn't discuss this at all, is how I got into this is I've had a very really diverse career set. I've worked in design, I've worked in marketing, I've worked in sales, I've worked in the renewable industry. One of my first jobs out of college was I was working for a medical trade association where mainly what we covered was radio diagnostic procedures and how to spot malignant tumors and targeted alpha therapy. I didn't put two and two together until about a year into it, but one of the things that we talked about were medical isotopes that could cure cancer, but they were exceptionally rare because there were only certain types of reactors. About a year later, I started getting into thorium, and the reason why, and look, again, you can run uranium in a molten salt reactor, you can run plutonium, you can run waste. That's all great, and I'll always advocate for that. But the reason why I look at thorium as the best use case for a molten salt reactor is in a specific type, which we refer to as a lifter. There are designs that are looking into using that to make electricity, and the waste byproducts that are made can make things like actinium-225, which decays into bismuth-213. I've heard stories of people being injected with this stuff, and these guys have like leukemia, they have lymphoma, they have all this stuff. This one guy in Utah got injected with this stuff, and about 2 kilograms of cancer was basically just killed in about 45 minutes. About 93% of the cancer was killed. And when I heard about what happened, I was like, what happened? Well, he died. I'm like, why did he die? Because we didn't have enough of this stuff to do a second or third follow-through, because this stuff is exceptionally rare. And it was a miracle that we just had, that we happen to have this stuff. There are only a handful of reactors on the planet that make it. What's nice about a lifter is you can make these materials just out of the normal processes of generating electricity. So, when I tell people
to see the article on that one tickles my.
Well, that'll be a little teaser for next episode.
At least something. Yeah.
I had fun. You guys bring me back anytime. I'd be happy.
It was
definitely
a real pleasure. Thank you so much.
Thanks very much, Sean. A real pleasure. Really enlightened.
Thank you.
Popped a lot of my misconception bubbles for sure. Yeah. I hope the audience is too.
Yeah, no problem. And hey, if you guys have any questions, or if you got anybody, coming in saying, hey, I heard about this about nuclear, if you want to email me or something like that, I'd be happy.
I will forward it right on and try and answer it myself.
Hey, this guy told me that if I just run into a vat of like molten thorium, that I'll get superpowers.
That'll be Chris. Yeah.
We'll be forwarding those emails to him. That'll be Chris writing you an email. Yeah.
All right.
Just for your own mental health, I recommend you stay away from the comments, man.
It's okay. I'm used to them at this point.
Yeah, but I'm a big fan of Reddit. I do think as that podcast guest exchange, we found some really interesting people, and I think, as I said, there's a lot of just people looking to have good conversations, right? Especially if it's not your main job, it's just an amateur hobby, a passion. But there's just really interesting people you can talk to.
Yeah. One of my favorite comments is when people ask me like general questions like, how small can we go? I'm like, well, how small do you want to get? I'm like, well, I want to power a farm in Africa. I'm like, you probably don't want this in your backyard, but I mean, I have heard of, one thing that the military was looking at was just really small compact reactors to power like forward operating bases, so they didn't have to import diesel fuel and have those convoys be, attacked by IEDs or anything like that. And, once they leave, they can leave the reactor to the host nation to just sort of power a village or to desalinate water to irrigate a desert or something like that. I've heard a number of applications, but what's nice about these reactors, you can make them so small, you can fit them on the back of a truck.
When you were saying how small, I thought you were thinking like a watch maybe or something like that. Like nuclear power watch.
I have heard there was a TED talk that somebody did. He was a young chap, really young chap, and he was talking about molten salt reactors. I'm not sure what the fuel was, but he was talking about molten salt reactors, and he was talking about them powering homes. Just, you have one per X number of homes. But the thing is, it's buried 50 feet underground. You never go down to it and touch it, and it's just a contained unit. Never operates, and if it failed, it just cools down and solidifies.
Could you do it? Yes. Would you want to? I mean,
Yeah.
no.
Yeah.
And again, and to Chris's point, you got a lot of people that are like, not in my backyard. Where we got a bunch of coal plants in this country that are probably going to be decommissioned, you know, just because. I mean, look, the Trump administration in the last 4 years has done a lot to try and change a lot of the Obama era restrictions on building new coal plants. And they were not that effective, to be completely honest. I mean, the reason for that is not because, you know, people don't want to burn coal. It's that, well, natural gas is just so much cheaper in the United States that it just doesn't make sense to build new coal plants.
Yeah, a lot of, we're going to get political here, but a lot of Trump's, we're going to bring back the blue collar jobs, right? And manufacturing jobs, and people are going to stop making stuff in China and start making it in America. I always felt was a bit disingenuous. I'm like, I don't think you're going to compete with China as a factory at this point. That horse is long bolted, right? Like, and it felt like, how many jobs are you talking about? Like 1,000 coal jobs? Like, it was a lot of big speeches. I get why people love it. I do feel for those disenfranchised people. But, as you say, not necessarily the most effective outside of the speech.
Well, okay, so I can't say the same thing about coal, but one thing that the Trump administration has done, and I've actually praised him on this, was we've actually had some serious efforts in terms of bringing back the rare earth industry into the United States. We used to be the #1 supplier for rare earth materials, and ironically, the reason why it got shut down is because during the START treaties, you know, when Gorbachev and Reagan were setting in, like, you know, terms of like what is acceptable source material, these guys don't know what that is. Like, just say this amount, and the mining industry started freaking out. They're like, you guys do realize that when we're digging up iron ore and stuff like that, that the radioactive, you know, source material that we deal with far exceeds that, you know, threshold that you set in. The other issue is we had a tailings leak, some thorium into the desert. Nobody died, obviously, because it's thorium. You could have 1,000 pounds of this stuff in your basement, won't kill you. But actually, you can eat the stuff, believe it or not, and your body wouldn't metabolize it. It would just go straight through. I don't recommend.
I was getting hungry when you were talking about the flavors of nuclear power.
I wouldn't regret it.
I wonder what it tastes like.
It tastes like sand, I would imagine. Well, no, because believe it or not, if you go to Florida, if you dig up a thing of sand, a lot of those beach sands have trace amounts of thorium in it because it's monazite, phosphate.
That's why Florida man has superpowers.
That was it. The same way that seawater's got shed loads of uranium in it, not from Fukushima, but just because.
But is that why the famous Florida man I keep reading about has superpowers?
No,
perhaps.
I can't comment.
He was
on
eating
Florida.
sand.
I can't comment on Florida man, although I probably should. I actually got my degree in Florida, so I've met a bunch of people. No, but no, I actually did an episode on this. It was the 4th episode we ever did. It was the one I was the most passionate about, and it got the fewest amount of views and the most negative comments that we had because I had so many people who were like, "You can't compete with China," and I was like, "Well, I didn't say that we were going to replicate what China did. I don't think you can because their government has just they can print trillions of dollars all day and they can subsidize them."
But as you alluded to, building on that, like if Australia, a well-developed country, can have a decent mining infrastructure, it's certainly possible in somewhere like America.
So we're actually so one of the things that we're doing now is we're actually partnering with the Australian government. Actually, not the government. I should be a little bit more. So there's a big mining company called Lynas, and they do a lot of different mining. They're in Malaysia right now, where they have a rare earth refinery, but they're only able to refine certain materials that they can get access to. They can't get the heavies. The funny thing is when people hear rare earth elements, they just think, oh, we don't have it. It's like unobtainium. We can't find it. And that's not true at all. That's not why they're called rare earth materials. They're called rare earth materials because of their electron configuration in the periodic table of elements. They have certain unique properties that you just wouldn't get through, alternatives, things like neodymium. A lot of people don't realize this, but neodymium has allowed us to make really efficient magnets. They go into things like these earbuds that I have right here. or
Yeah,
they
all the
can be
speakers,
used,
right? Yeah.
or the magnets that keep the rotors in suspension for wind turbines. You know, if it wasn't for neodymium, we wouldn't have that. Same thing goes for lanthanum. There's lanthanum in the camera lens that I'm using to talk to you guys right now. It's also used in electric car batteries. So there's a lot of stuff. It's not rare. It's they're actually, a lot of them are pretty common, but the reason that we're not mining them is because we have all of these, you know, superlative regulation and a lot of misinformation in regards to source material. So one of the things that a lot of the thorium guys in this country advocate for is something that we refer to as a thorium co-op. So what we're looking to do is we're hoping that we could pass legislation, and there have actually been a couple of congressmen that have actually pushed some legislation towards this effect, is where we would have a basically a thorium storage facility, and where we would have that funded through, like, say, storage fees from the mining companies, and they would just pay the company, let's call it the thorium bank, to just store this waste thorium as a byproduct of rare earth mining. Just take away that liability from them, and we would just have the authority from Congress to develop markets and uses for them. While we're doing that, the rare earth industry can process millions and millions of tons of rare earth materials, and that would allow us to have a domestic supply chain in the United States. Now, you're absolutely right, Chris. I don't think that we can bring every single job. Like, you're probably not going to put the steel workers back into work. You know, I mean, actually, we're talking about doing an episode on how you could, by utilizing the molten salt reactor, because the energy would be so much cheaper that you could make that cost effective. But in this country, in the United States, and this is a specific use case for the US, I don't know if the UK is the same way, but in the United States, we actually have a number of laws that require the defense contractors, companies like Lockheed, Boeing, Northrop Grumman, to develop a lot of the components for things like the F-35, the Patriot missile launcher, the Patriot missile system, all these different technologies, the drones, the Predators, the UAVs, all this stuff uses rare earths. And by law, they are required to make this stuff domestically or through allied components, of which China constitutes neither of them. The reason why they get away with it is because we don't have a domestic supply chain. So when the defense industry goes to before Congress, they can request exemptions, and they're getting it because the case they're making is, we do it if there was a supply chain. There is no supply chain, so we have to get it from China. That's very dangerous from a geopolitical standpoint, because if, God forbid, you ever go to war with China, and I really hope that we don't, I actually had an episode where I said, don't do that specifically because of this reason. That would be an issue. But if you
It'd be like negotiating with your ex-wife.
Yeah, it's an unwinnable situation. But if you had this co-op, if you had this, thorium storage facility where you could allow the rare earth mines to just open up for business, while we're trying to figure out the thorium stuff, you would have these companies who are required by law to hire U.S. workers to develop a U.S.-based supply chain. So you actually could bring a lot of these jobs back domestically. I've actually looked at the math, and even if I don't think you can replicate China on that scale, but because we're only talking about a $4.5 billion industry, but that $4.5 billion industry is the backbone for a $7 trillion electronics manufacturing economy. So if you're only tapping into maybe 15% market share, that's $1 trillion worth of gross domestic product that you could bring back into the United States. And, I feel like the reason why that hasn't been, pushed very heavily is because no one is framing the conversation in that direction.
Just quickly, because we're about to launch another episode.
Oh, I'm sorry.
No, I love it. Do you know if there's anything earmarked in the Green New Deal for nuclear?
Well, if we're talking about the one that AOC tried to push when
there's a few Green New Deals now. So
yeah, well, there was the original one. There's the OG Green New Deal, and then I think I haven't looked at the all the details.
There's AOC's one, and then I think Biden's got his own one as well.
Biden has a significantly drummed down, so it's not 93 trillion, it's like 2 trillion or something like that. I haven't read the bill myself, so I haven't, and we'll probably end up doing an episode on that. So if you want more information, I'll be happy to provide you that. I'll send you the link, actually.
Brilliant, and we'll have if you send us links, we'll have that all below in the show notes.
To my knowledge, no. To my knowledge, no. It doesn't look like it's been included. It'd be great if it was, but if it is, that's something to talk about on the episode. That just gives me more stuff to talk about on future episodes.
Brilliant. Well, no, I really would like to do another episode on future tech and some other things. Thank you so much for coming on and sharing all your knowledge and insights.
Yeah, thanks for having me. Thank you. It's been great having you.
Take care, guys. We didn't really do much of an intro or a sign off, but at this point, I don't think we need it, do we?
They know where we are. Oh, you can subscribe to our Patreon, can't they? People can
I'm actually tempted to sort of cut this episode in half and be like, if you want more, you got to pay. You got to pay.
Oh,
that's harsh. I don't think we should. No. I think we could like do those other chats on the planning.
Nah, we've just started a Patreon.
Yeah,
I mean, it's very early days, isn't it? So.
Same here. We just got to we just got our approval from YouTube to do monetization, and we're going to be launching the first new episode of the new year tomorrow, hopefully, if we get it edited in time. But yeah, we're hoping to have it released by either tomorrow or the next day.
Good luck with that, man. Like, really, a fantastic year.
Thank you. I appreciate it. And yeah, I will probably, if you guys want to have me on the show again, hopefully at that point, I'll probably have some more materials that I can start distributing to people, because that's really where we want to go long term. We want to be able to provide basically tools for people like yourselves to just share this with others so that we can actually expedite this, because it's really important.
Right.
Yeah, it's one of those topics where the initial hurdle to starting to learn about it is quite high. But then once you get over that and you're like, if you bluster past that and just get to people such as yourself summarizing it, I'm like, oh, this is really interesting.
Yeah,
for sure.
But I was lucky. I did a module of nuclear physics at A level.
Really?
So I just about blustered my way through it.
Yeah. So I've actually had some people ask me, it's like, yeah, you really know your stuff. And I haven't really heard anyone really dumb it down to where people can understand it without, I mean, you actually sound like you know what you're talking about. Where did you go to school? I went to Full Sail. Like, oh, cool. What'd you major in? Digital arts and design. So where did you learn about nuclear power? It's like my first job out of college. I kind of learned this by accident because I had to do it because I had to do some editorial stuff for the stuff that I was doing design work on. And then the rest just sort of came in here. So
I think though that's so important though, because obviously at an academic level, it's really valuable to have a bunch of super specialists communicating in a language only one another can understand. but if you don't have a generalist who has communication skills able to disseminate that information with the world, then it doesn't leave that nerd's meeting, right? That's the problem.
Yeah. Oh, what time is it? Oh my God, we've been on here for 2 hours.
Yeah.
That flew by. It really did. It was fascinating.
West Coast, you're 5 o'clock? No?
We are right now. I've got 1:54 p.m.
Oh, wow.
What time is it over there?
It is 10 o'clock. Almost.
I'm in Spain, so I'm 11.
Gotcha. Well, I would say if you guys have me on in the next 3 to 6 months, I'm probably going to be moving to Texas, because that's where we're going to be incorporating.
That seems to be where everyone's
moving out of California to Texas.
Yeah. There's a reason for it. I mean, it's just I could do a whole episode of why I'm leaving California, but apparently that I'm not the only one who has. But yeah, what it is it's just the cost of living here is exorbitantly high. And as far as I mean, the government, the state government here hasn't really done a great job from an economic standpoint in terms of dealing with the homelessness crisis. In LA where I live, we have something like about 65, like almost 70,000 people who are homeless, which is
my co-founder's from Eastern Europe, and when he spent some time in LA and San Francisco, he felt scared for the first time in a while.
San Francisco. I don't know what's worse, by comparison, because I've been to San Francisco, I've been to the Tenderloin. It's horrible, but and I don't know. I just feel like the politicians that keep getting reelected in California haven't really learned the lesson, and I don't see that anyone else from the opposite end of the spectrum getting elected. And
for so long we were chained to an office somewhere, right? Which had to be in a popular central location. Any company that survived the last year with everyone working remotely, you've suddenly realized it doesn't actually matter what city I live in anymore.
So I actually just passed the 1 year mark on my job, on the job that I currently work at right now. I work in enterprise sales for a software company, and
Yeah, that's what I do too.
yeah. Oh, cool. So yeah. Yeah. For 2 months, I was like learning the software, talking to people, forging connections. And then on March 20th, my boss says, "Hey, we got to have a meeting." It's like, okay, here's the deal. I just talked to County of Los Angeles. They're shutting down the city, and they're probably going to call the National Guard because of they're trying to mobilize and do all this stuff to help address all the sick people who are homeless and all this other stuff. So get your laptop, get all your stuff. You're probably going to be working from home for the foreseeable future. And I was like, okay, cool. I get to spend the next couple of weeks working from home. Turns out I've been working from home for the last 10 months. Yeah. And it doesn't look like that's going to change anytime soon. So I'm actually going to talk to my boss and be like, look, you already have me working from home. Could I do the same thing, but in another state?
Well, because Johnny was just saying he's, making calls to Vietnam. So he often does strange hours. Right? Yeah. It's the new world.
Yeah. I'm teaching online too. So I teach people from all over the globe,
Yeah, I don't think I've talked to a single client that is in the exact same time zone that I'm in. Everyone I'm talking to is from a different time zone. So to me, I just don't see any point in staying and paying the exorbitant rent prices when I can get something that's much nicer for several $100s less than what I'm currently paying right now. Exactly. So to me, it just makes no sense.
Don't you just love sitting in those big 6 or 7 lane wide car parks that are the interstate?
Yeah. I'm not gonna lie. When traffic was when I was driving, regularly, the traffic was a nightmare here. It's not an exaggeration. It's pretty bad. It's actually worse than it is advertised in most movies.
I was gonna say I had misconceptions going to America, so I came over to see you about. Not you in particular, but came to see you guys about 2 years ago, and I always thought, big cars, big roads, lots of driving, and I was in San Francisco, and I thought I'd drive up to the Golden Gate and have a look at it, and I was on an interstate which was 7 lanes wide in a hire vehicle, and then there was these big 18-wheelers, and they are big, like trucks in the UK aren't as big as that thing. No. And I was driving next to this thing in this lane, and I've gone, this motorway hasn't got any bigger than they built it, and they've just put more lanes in it, and there's these guys in these super Thunder Patrolmeister vehicles driving past me, like almost scraping alongside me, and I'm sat on the wrong side of the car with the gear stick that's on the wrong hand going, this is not what I was expecting. No. Not as easy as I thought it would be.
So fun fact, I don't own a car. I don't drive. Well, I drive. I have a license, but it's just like the funny thing is I've always admired people who are able to get away with living that lifestyle, to not own a car and not have to deal with the superlative taxes or fees and all the other stuff that comes.
Surely that'll change in Texas. Get a gun, get a car.
Yeah, I mean, I don't know. My girlfriend and I, we have an argument of that. I'd like to get a gun. My girlfriend doesn't want to get a gun, but
you don't need one in
you
Texas.
can make a compromise. Get an air rifle, innit? Get an air rifle.
Well, she wants to buy a crossbow, actually. So
seems like a quite a good compromise.
Walking Dead, isn't it? She's thinking, if it's zombie apocalypse, I need that bolt recycled and.
Yeah, I mean, I don't know.
It sends a message out. A lot of people have a gun. Not enough people bring a crossbow to a gun fair.
Not really.
I am one crazy motherfucker. Back the fuck.
There's this guy I subscribe to on Germany that makes these really cool custom like crossbows or whatever that just like auto reload or whatever.
I think I've seen him. Yeah, does he does a lot of stuff at the range?
Yeah, he does a lot of stuff. He took one of those motors from like one of those electric drills, and he basically made like a full auto crossbow gun out of it. And I'm like, this guy's this guy's fucking cool because
he's living his best life.
He's in Germany. This is a country that has probably one of the most stringent. I don't know what the law is in Germany for owning a gun. My best
strict. It's like most of Europe.
So from what I know, you have to be a hunter and pass a hunter's test. So you show that you're only hunting for conservation purposes, which species in which seasons should you be killing, and So it's heavily regulated, but some people go through the hoops to get it.
Yeah. There are a lot of misconceptions about the U.S. in terms of the gun regulations here. And,
oh God! Send me some resources on that, because we're talking to. I don't know if you know her, but she's a YouTuber called Tactical Girlfriend. It's the most Portland thing I've ever seen. So she's like super like Antifa, and she's teaching like those people how to arm themselves, and they're traditionally anti-gun.
Oh,
and she's
Jesus
like,
Christ!
No, we need guns. And like it's amazing. But I'm having a chat with her. I have no idea. I don't want to sound like Piers Morgan talking about the gun debate. So if you have any resources you can share with me, so I don't just sound like an idiot European.
I mean, that I wasn't expecting that. When I heard Antifa, I'm like, okay, so she's probably going to tell you why guns are bad, and like, I was thinking,
she's like, we need to be armed.
Yeah,
Jesus Christ.
Dangerous now.
Well, yeah, I don't know what to say about that. I mean, what kind of statistics were you guys going to go over in terms of?
Well, so it's been interesting recently with the NRA declaring bankruptcy. They had a massive lawsuit in New York. Yep. New York just sued them out of existence. They had a big internal civil war because the guys at the top were spending a lot of money on private jets and the time in the Playboy Mansion, and everyone was like, I'm not really sure how this is funding our needs as an organization.
Not sure what that has to do with guns.
I don't either. Like, don't get me wrong. I'm not a card-carrying member of the NRA, but I'm from Virginia, and one of the NRA headquarters is located in Virginia. Like, people are like, hey, have you ever been to the headquarters? Have you ever seen the? Yeah, I used to get my dry cleaning done across the street, and people think I'm joking. No, like legit. I'm from Fairfax County. Like, literally, the place I would go to get my dry cleaning is right across the street from NRA headquarters. Just like, but no, I mean, I don't know. I mean.
A big debate I'm hearing, and I'm finding conflicting sources, is whether the number of shootings has gone up or gone down.
Right.
And okay, well, this year's a write-off for all statistics because
COVID and who the hell's going out.
No one's going to school.
No one's going to school. Which is probably a good thing. No, I mean,
there's a bunch of nerds in black coats like, there goes my plans for the year.
So in the United States, and I will make the argument that it is pretty high. I mean, when things were normal pre-COVID, we were probably looking at something like about 32,000 gun deaths. Now, again,
America's like China, though. It's such a big country that every statistic sounds like, whoa, okay, put that in.
A lot higher than that.
Yeah, and people. I mean,
it's not ideal. It's 32,000 deaths.
I'm not. Just to be clear, I'm not advocating for the death of children or anything like that. When I say that, I just like, no, that's just the fact that we've had 32,000 deaths recorded per year. Now, here's the thing. It's gun deaths. It's not shootings. So that they're not accounting for suicides and accidental deaths and stuff like that. If you hammer that down, it's more like something like about 10 or 12,000, which again, it's still high, but we're also not accounting for the fact that a lot of this is having in, poor inner city communities where there are less, opportunities, for certain people. And there's
and it's gang crime and drug related. And I think another thing I've seen is, people always focus on the AR-15 that can be modified to be a semi-automatic, whatever, right?
Yeah.
But if you break that down, most of it is handguns. And a handgun ban would be very unpopular and hard to legislate, right?
Right. Where AR-15s are like, they're scary looking. It's like, well, you don't want to ban a gun because it's scary looking. You want to, if you're talking about banning it's not the point. The point is what's causing the most damage. And if we're statistically, if we're talking about gun deaths, you're absolutely right. It's coming mostly from 1911 Colts or just like handguns or Glocks or anything and stuff like that. So you're absolutely right. The other thing to take into consideration is, if we're going to be truthful to the numbers, in the United States, we have the Second Amendment, which, was put in there for several reasons, but
school shootings are bad, so I am sympathetic to the.
Well, school shootings
can't
are
we
bad.
do something? Like, can't we ban the gun behind most school shootings?
Well, school shootings are bad, but what's also not talked about that often is, and this was studies done by the CDC and by the National Safety Council, that there are anywhere between 800,000 and 2 million lives saved from legal gun owners. And I asked somebody who pulled up those statistics, like, why is it so varied? Because that seems like a pretty weird.
I have seen someone question those statistics, though, right? Like,
right. So
there's a big, powerful gun lobby behind those statistics.
Right. So, but I asked that this seems kind of varied, like between 800,000 to 2 million. It's like, well, it's hard to gauge who's actually discharging a weapon and who's actually just brandishing a weapon, saying I have a gun. don't come near me. So that's kind of part of where the confusion lies. But again, and by the way, you guys are absolutely right. One, about the handguns, and two, about the fact that yes, it's a lot, but I also live in a country with like 328 million people. So on a per capita basis, it's not as high.
Still pretty high though. I mean, like Europe's got 500 million, and the deaths are way lower. Right?
Sure. And you guys have very stringent gun control
really
policies
strict.
and stuff. Yeah.
Just to change the subject quickly, have you seen that series Dark, Sean? It's a series on Netflix. It's like a German series.
No, I have not.
You might like it because it's to do with nuclear. It's not to do. It's to do with time travel. It's obviously science fiction. I don't want to give too much away. No, but it's to do with a nuclear power plant. That's like the sort of protagonist of the show is set around a small town in Germany and a nuclear power plant. I don't want to give too much away because it's a really cool series. You'd probably quite like it, I reckon. Yeah. Because it's a little bit.
As an
expert, it's kind of based on real stuff.
No, that's not right. No,
that's
not right either. No,
that's way too many barrels of nuclear waste. So if you go, I don't know, but it's really cool. It's to do with time travel.
It's called Dark.
Dark, D-A-R-K. Yeah, really good.
Not Schwarz.
Let me pull this up on Netflix.
It's really decent. I mean, it's like there's 3 seasons, so it's a little bit of a watch.
Okay, it's a thriller,
but it's pretty cool.
Is it subtitled or is it?
I've heard it.
In Netflix you can change a language, right? But I watched it in German.
Someone said it's English. A bit like Stranger Things, but they
kind of. It's really well acted. I have to say, it's really well acted, well written.
For German,
the music's cool. No, it's really good. I picked up a lot of German from that. The main thing is they say I've got to go, and then they mysteriously disappear really quickly, like David Cameron. Ich muss los. And then they just disappear like that. They just I have to go, and then they just shoot off somewhere, and you're like, what? Yeah. So if I go to Germany, I can disappear.
That's how Germans
all of a sudden.
Germans end conversations.
They don't turn their back on you, and they just slide.
They just slide.
If they're your friend, they'll be like, "Oh, I'm going for a shit," and you're like, "Thanks for sharing that."
I mean, in Britain, we always tell people what we're going to do before we're like, right, I'm just going to go to the toilet, and they're like, okay, he's going to the toilet. And in Germany, it's just I have to go. It's so mysterious. Yeah.
We've all got bowel problems. This is really urgent.
Yeah, I must.
Why? I'm learning so much. I thought I was going to be teaching you guys about. I'm learning so much about what goes on.
What really goes on? Yeah.
What really.
Gentlemen, I'm officially calling it at that point. Thank you so much.
Yeah,
I have one more question before we sign off. Have you guys, because we were talking about guns, have you guys ever discharged a firearm or used an AR-15 or anything like that?
Yes.
Yeah.
But not a big one.
Air rifle. I used to have an air rifle. I love that.
Done an AK-47 and
really?
Well, this was at a range in Cambodia. So.
Oh, damn.
Pretty safe.
I've shot
safest way to fire.
Plenty of 22s, 12 bore.
Yeah. Well,
why'd you ask?
No, just because I'm
Curiosity.
moving. Well, I'm moving to Texas in a couple of months, and I was just going to say maybe in a year or two when things kind of get normalized with this whole COVID thing and you guys are travel, if you're ever in Texas, come over and my producer and I will take you out to the
range. With pleasure. Thank you so much for the invitation. Because we just did a great episode with, they were called Realpolitik. I think they've just rebranded to the Southern Liberal. So they're based in Carolina, I want to say. And then I've got some other friends in Georgia. Mm-hmm. So I'm planning a trip of the South. And I would
wonderful.
Come see, man. That'd be amazing.
Yeah, cool, the Carolinas are nice. A lot of topless bars there, actually. If you're into that sort of thing.
I'm in the mood.
Chris, a topless bar.
If it was a bit warmer.
You never think about these things, but for someone who had to drive like pretty regularly between Florida and Virginia, it's like an 800 to 1,000 mile trek. And you go on the I-95 corridor, and once you get to like North Carolina, you'll see like at least like 15 to 20 different signs for like topless steak. It's like,
you were the guy that was like, I'm just here for the steak, ladies. Like, if we can just keep this professional, please.
Yeah, I'm in a stable relationship, but this is some really good sirloin, I have to say. It's like, so I'm just throwing it out there. If you like topless women and you like steak, North Carolina.
Guns and tits, come see me. Yeah.
Oh yeah.
That is an invitation and a half.
Yeah, pretty much. Let me know. No, but seriously, if you're ever stateside, give me a call and
I will take you up on that. And I'd love to do an episode in a few months' time as well and talk about.
Yeah, that'd be grand.
We'll probably. we're hoping April or May to make the move happen. So probably by June we'll be settled in. So yeah, if we want to do another episode then, let me know.
That'd be brilliant.
Cool.
Thank you so much, guys.
No problem.
Man. Cheers,
All right, everyone. Lovely to see you all.
Thank
you.
Take care. Ciao.